Gauss law in electrostatics. Let us take the statement. It states that the net flux phi E enclosed by any closed surface is equal to 1 by epsilon naught times the total charge capital Q enclosed by the surface. Phi E is equal to Q by epsilon naught. Here, epsilon naught is the permittivity of free space. Now let us take the proof. So proof of Gauss law. Now consider an enclosure of any shape you wish. Let a charge capital Q is placed here at the point O. Consider a point P somewhere else, anywhere you can take. Consider a point P, and at this point P there is the electric field E bar. We want to calculate the flux emitting from the total enclosure. So for that, consider a small elemental surface ds, and this ds direction is in this direction, which makes an angle theta with the field direction, and our interest is to calculate field along the field direction, that is normal direction ds, that is ds cos theta. Now the radius, let us say capital R, O2P is the radius. So now we are taking, consider a charge Q in a closed surface at a point O. Now consider a point P on its surface. On its surface, and let ds be the area vector of an elemental surface at P. At P, this is an elemental surface at P. Let ds makes an angle theta with E bar, where E bar is the electric field at P. At point P, at the point P. Fine. Now we want to calculate the flux from the small elemental area. So the flux through the elemental surface ds bar is d phi is equal to E dot ds bar, that is equal to E ds cos theta. A dot b is equal to ab cos theta. So that d phi is equal to, here the flux is electric flux, na? So let us keep it as d phi e, no problem. Simply, as we know that we are in electricity, we can keep in general phi, no problem. So d phi e is equal to e ds cos theta. Now ds cos theta is in the same direction of e. Our intention is to calculate the total flux by coming out over the surface, through the surface. So this is our intention. For that, total flux is equal to, we take integration over the closed surface. Total flux phi is equal to integral of, or phi e, let us say d phi e, that is equal to, we have integral of e dot ds cos theta, e ds cos theta. Now that is equal to e value 1 by 4 pi epsilon naught into q by r square into ds cos theta. Since electric field at a point is known for us at the point P at a distance small r is given by 1 by 4 pi epsilon naught into q by r square, here the distance is r. This we learned in the electric field. So that is equal to, let us take out the constants, 1 by 4 pi epsilon naught into q is also constant, integral over ds cos theta by r square, here capital R square. Now we discussed in the previous class that ds cos theta by r square is the solid angle made here. This is the solid angle made, let us say d omega is the solid angle made by the surface, right? So the projection is also there, it is ds cos theta. Whatever may be ds or ds cos theta, both will forms the same solid angle d omega. Then we write 1 by 4 pi epsilon naught q into integral of d omega. Now we know the total solid angle is equal to, we know that is 4 pi simply. So we write that is equal to, phi e is equal to 1 by 4 pi epsilon naught into q into 4 pi. Now 4 pi gets cancels, remains q by epsilon naught. This is the total flux, electric flux coming out from the surface. It's very easy. So only the total solid angle made at a point is nothing but 4 pi steradians. Just we learned in the previous class. This is how we can prove this. Clear? Fine. Now if there are n number of charges inside, let us say q is equal to, if q is equal to q1, q2, q3 and so on plus charges, and there may be minus charges, minus q1 dash, q2 dash, q3 dash and so on, and the total sum of all the charges, that is plus q plus minus q dash, put together you will get the summation of charges, all charges, summation of, let us say, charges, all charges, that is the total charge. So this is applicable for the any number of charges inside. This we can understand. Or where simply you can write where Q is equal to this much. Here itself you can stop. Right? This is the total charge. Now let us understand this Gauss law in different forms, that is integral form and differential form. Now Gauss law in electrostatics is given by phi A is equal to Q by epsilon naught. This is the formula we have. Let us take this in integral form. First, we know flux phi E is equal to integral of E dot ds. First point, integral of E dot ds. And second, charge Q can be written as let us say small charge dq is equal to charge dq is equal to rho into dv, charge density into volume. Now total charge q is equal to volume integral over the charge density into v. Here charge density is defined as charge per unit volume, that is equal to small charge by small volume. So this is how we can formulate dq is equal to rho dv. This we call charge density, volume charge density. This is say equation number 3. Substituting 2 and 3 in 1, we get, what shall we get? Here integral of E dot ds is equal to, this is surface integral, this is volume integral of rho dv. Rho depends on the radius. So if you take, as you are moving away, the charge density may change. So this is known as integral form of the Gauss law. This is the integral form of the Gauss law. Now let us take from this integral formula form of the Gauss law, let us take a differential form. We have integral form of Gauss law. Surface integral of E dot ds is equal to volume integral of rho dv, charge density into volume. Now from Gauss divergence theorem in vectors, we studied in the first semester. So for Gauss, from Gauss divergence theorem, we write surface integral of any closed surface E, that is S, E dot ds can be written as volume integral of divergence of that vector into dv. This we can write. So this is Gauss divergence theorem. Let us say this is equation 1, this is equation 2. Now substituting 2 in 1, we get volume integral of del dot E dv is equal to volume integral of rho dv. So we write del dot E is equal to rho. Sorry, here we got epsilon naught in all the cases. In the previous one also I erased that. Epsilon naught from Gauss law, we forgot that. Q by epsilon naught is there. Right? So this is the differential form. Let's say equation 3. Right? So now 3 forms of uh, Gauss law in electrostatics can be written as number 1, phi is equal to q by epsilon naught. Number 2, surface integral of E dot ds is equal to volume integral of rho by epsilon naught into dv, and here del dot E is equal to rho by epsilon naught. This we can understand, right? This is general definition, and this is integral form, this is differential form. These are the 3 different forms of Gauss law in electrostatics.